Hello, this is the second question of the January 2011 paper for AQA blah blah blah. So this question is mainly about projectiles and projectile motion. So I've drawn a basic sort of diagram of what you might get, of what you got in the paper. Now obviously mine isn't as detailed because it's a quick sketch, obviously. This is meant to be the tower, the cannon going off there, hitting this ship. There should be a ship there. Height 67 meters. This is 150 meters. I've drawn Vx and Vy even, and it should get you what you need to know. Now the first question, 2A part 1, I assume it's called, which isn't going to start. It says show that t equals 3.7 seconds. Now, we don't know the initial velocity, we don't know the final velocity, all we know is the height and the length it sort of hit. So, how can we possibly work this out? Well, we know that the acceleration is going to be 9.8 meters per second, or 9.8, sorry, Vy. It's asking us when it hit the ground, so it's going to it's not asking us how long it took to do this, it's how long it took to hit the ground, so it's going to be to do with the height. Now we know this 67 metres equals y, which is the vertical displacement. Now Vy is the velocity in vertical position. So we know y equals half of gt squared. Now to do that, what we can do is plug in what we know. So obviously we know y is 67 metres, half of g, which is a half of 9.8, which is 4.9 I think, times t squared. So what we do is sort of move this around, so if I've done this right, 67 over 4.9 equals t squared. So I'm trying to get out of the way a little bit, some work. So we can say the square root of 67 over 4.9 is going to equal t. And it said t should equal 3.7 seconds. And sorry, I don't know why I've done it. It should be 2 times 67, sorry. Yeah, over 9.8. Actually, no, that would work as well, actually, sorry. So, yeah, that would work. Or you could have done, if you could have left it as, you could have times the whole equation by 2 to get 9.8, whatever. I feel it's more beneficial. The mark scheme does say 2 times 67, root of 2 times 67 over 9.8, but obviously that's going to get you exactly the same answer as 67 over 4.9 and the root of that. Oh, I am fairly sure it will do anyway. So that's the first part of the question out of the way. 2A part 2, yeah, there is that. Obviously I'm going to rub this off when I start running out of room, but I'll leave it on for the moment. It says, calculate the velocity at which the cannonball was fired. Now, if we know the time is 3.7 seconds, now I'm doing all this without a calculator, because I'm using a mark scheme for my calculations, but I would still be not using my calculator until I finish the equation. I just having to plug in the numbers if I couldn't do it in my head. And that is because purely, if you put rubbish into a calculator, you get rubbish out. And by that what I mean is, if you put something wrong into a calculator, it's going to give you the wrong answer. So you need to think about it logically before you start punching numbers in your calculator. Obviously I just use my fist, I don't actually use a finger to push the buttons. That's just used for maths. But anyway, so basically it says calculate velocity at which a cannonball was fired. Now, how do we know what? So is it Vx or is it Vy that's going to give us a horizontal velocity? So it's fired horizontally. So it's going to be the horizontal velocity. So Vx equals a horizontal velocity. And as it happens, Vx equals u. Vx equals the initial velocity. But what also equals the initial velocity? It's going to be something to do with the horizontal. So it's not going to be the vertical displacement, it's not going to be the vertical velocity. And now we know x for this equals ut. Now these are just equations you should be familiar with. So x equals ut. We know x, we know t, but we don't know u. So basically all we do is rearrange the equation. So t, sorry I shouldn't put an arrow there. So we know t is 3.7. We know x equals 150 metres. This is why writing stuff down before you do the equation is so much simpler. Because we now know, we know x, we know t. Now before we even look at any of these equations, you should know that this speed, distance, time sort of thing. So we look for the equation which has got displacement and time. And the displacement is a horizontal displacement, so it's going to be a horizontal displacement equation. So we just plug these numbers in. So x equals ut, we can rearrange this to get u as the subject to the equation. So u equals, x over t, I think I've done it right, simple rearranging, but you never know. U equals 150 metres over 3.7 seconds. So if we do that equation on our calculator, which actually I've rounded it up from 3.7, it's 3.69, which is what you should put in your calculator. And if we sort that out, that's 36 metres per second, it says there. That's your final answer. Oh, so is that for them. So that's your 2A part 1 and 2. Now I'm going to do 2A part 3. It says, calculate the vertical component of the velocity just before the cannonball hit the ship. So, it says, vertical component of the velocity. Now, what we're not doing here is we're not finding out the overall velocity or the resultant. What we're doing is finding Vy. And now, you should know, Vy equals, what is it? Minus gt, I think it is, or gt, sorry. Yeah, that's right. So, sorry, just think about that for a second. So Vy equals gt. Now we know g, which is 9.8. Obviously, I'm writing it up here, but you write it as 2A part 3 because I can't fit it on my board. I just turn over the page. We know g, 9.8. We know t, 3.69. So we plug in our original value for t. Now we just do this equation again. If you couldn't remember the exact value of t, so to be as accurate as you can, you don't round it up. You use the exact value you've got for 2A part 1 times t, which is 3.69. Vy should be equal to oh damn it, sorry. This 2A part 1 was actually 41 metres a second. Sorry about that. This should be 36 metres a second. Sorry, I got it the wrong way around. So just to go over that again, I messed up because I wasn't doing the calculation in my head. I was just reading off the mark scheme, read it wrong. So 2A part 2 is 41 metres a second. 2A part 3 is 36 metres a second. All we did was we just substituted in the equation. So now we know the horizontal velocity at the moment of impact, and it doesn't lose it because it's not affected by gravity. And we know the vertical velocity. So just thinking about it when it hits the ship. Now just thinking about it, even before we look at the next question, we've looked at the horizontal displacement. We've looked at the horizontal velocity, the moment of impact. We've looked at the vertical velocity. The horizontal velocity, which is always u because it's not changed by gravity. And we've looked at the horizontal, then we've looked at the time, we've looked at the horizontal displacement. So the only logical thing for us to do is work out the resultant velocity at the end, which is what the next question asks us. So I'm just going to rub out the main bits actually. So if you need to get this down, you can pause the video now and just have a quick go over that. Okay. Don't you do much time in the mind. So I'll just write 150 back on here. 50 meters a second. Oh, sorry, meters, sorry. So the next question, to B part 2, it's asking us find the resultant velocity when the cannonball hits the ship. So 2B part 2. Now we know, what we know is we know Vx equals U, and we know U from a previous equation. Sorry, just make sure we've got the right thing here. Oh no, sorry. Yeah, sorry. It's asking us to find the direction as well. Sorry, I missed out that. So Vx equals U, 2B part AV. It's actually 2B, what? Sorry, I don't know where I got 2B part 2. It's actually 2AIV, which I'm not 100% sure what that is in Roman numerals, but I think it's 4. So Vx equals U, which is 40 point meters per second, 40.56. Vy equals 36 point Now, what you may see here, now if you don't know how to work out the resultant velocity of a projectile, what we've got here sort of looks like a right angled triangle with a missing side, which is kind of what we do. Now we use year 7 work again, not very good. We use Pythagoras, which is you know, a squared plus b squared equals c squared sort of thing. But obviously we put the velocities in. So a correct way of writing it is Vx, v subscript x squared plus v subscript y squared, and that's all to the power of a half. So basically it's Vx squared plus Vy squared square root, essentially what it is. So if we substitute them values in, I'm not going to do it, but 40.56 squared plus 36 squared, square root that, you should get 54 meters a second. Now what we've not done there, we've not found the angle which it wants us to do. So these are our two velocities. So in the end, our velocity of Vx, which is U, when it hits the ship here, it's 40.56, and this is 36. So what we do, we could use tan, for example, because we haven't got the hypotenuse. So it's basically basic trigonometry. So tan theta equals 36. Sorry, I'm going round. 36 over 41. Obviously, it's not 36 over 41. It's 30 point over 40 point. When I say what it means is just I'm not having a midlife crisis, obviously. But what it means is I'm just filling in the gaps, sort of thing. You know, it has extra numbers at the end, which might make a difference, which it does. So that means theta equals the inverse tan of 36 over 41. And that should get you theta as 42 degrees on the horizontal. So 42 degrees from the horizontal. Don't forget to add that bit at the end there. Sorry, I've got sort of cold, mad. Breathe through it. So the overall velocity is 54 meters per second. So I just run this out again. The overall velocity is 54 meters a second, and that's the most of that question done. And we've still got a bit more. You could have done that by scale drawing, but I just think that's a bigger area for error. Now I'll rub all this off, actually, all the information here, because this next question, all it's asking us to do is otherwise, all it's asking us to do is explain the energy changes that take place from sort of the cannonball hitting from the cannonball leaving the tower to hitting the ship. and this is the last part of the question. Sorry. Now, the reason I've rubbed all that out is because you don't need to explain in terms of the velocity and stuff. All you need to do is talk about the energy changes that take place from here to when it hits the ship. Just draw this big ship. Obviously, most ships, look like this. You've got a little thing there when it's under its towing. Good ship, that I think. It looks like a tower with some spike on the top. Now, it's asking us what are the energy changes that take place. So basically, at this point here, it's got no kinetic energy, but it's got a high amount of gravitational potential energy. And assuming that no energy is lost due to resistance forces, such as air resistance, for example, or is otherwise known as drag, as it falls, it loses kinetic energy, gravitational potential energy even. And now, because of the conservation of energy, that energy has to be conserved somehow. So, if it's not being kept as kinetic energy and it's not being lost to resistance forces, then it must be being transferred to kinetic energy as the cannonball accelerates towards a ship. Now, you could say the resistance forces are lost, and some of it's lost to resistance forces. But as it gravitational potential lost, it changes into the form of kinetic and resistance forces, and then it hits the ship. It says include the effects of air resistance. Sorry, I missed that bit. So basically, overall summary at the end of this question: there's no kinetic energy, no resistant forces, and high amount of gravitational. And as it's fired, the gravitational decreases, it starts to lose height. That's transferred to the kinetic energy and the resistance forces. And as they build up, the resistance forces is equal to the kinetic energy. Basically, the gravitational potential energy. So basically, gravitational potential energy high, kinetic energy and resistance forces low. The gravitational transfers to kinetic and resistance forces as it increases. It slowly reaches terminal velocity. Well, it could reach terminal velocity. Scratch there. Never mind. And then when it hits the ship, all the energy is transferred and is sort of impacted. The resistance forces are the total force of the cannonball is impacted on the ship, and it causes a big hole, many deaths, etc. So hopefully that's. I mean, there's only 2 marks there. Probably said a bit much, but that's the end of question 2. In our next video, we'll be going over question 3 of the paper, and we'll see you in the next one if you've survived.